If we have zeros of a polynomial, then it is relatively easy to find the multiplicities. We'll have to factor the polynomial completely and use exponents to indicate multiple factors. And we have to remember that if x minus c appears in the factorization, then c is the zero and the exponent of that factor x minus c indicates the multiplicity. So in my example, I have function f of x equal 2 times x minus 3 times x plus 2 times x plus 3 squared times x minus 5 to the fourth. I have multiple factors of the form x minus c, and therefore I will have multiple zeros. I will go factor by factor and find out zero of that factor and the multiplicity of that zero. First factor that appears in that factorization is 2. 2 does not produce any zero because it's not of the form x minus c. So the first factor that will produce the zero is x minus 3. X minus 3 appears once, so the zero is 3 and the multiplicity is 1. The next factor is x plus 2. So the zero is negative 2 and this factor appears just once, so the multiplicity is 1. Next factor is x plus 3 squared. This factor gives me 0, negative 3, and its multiplicity is 2 because the exponent of that factor is 2. The last factor produces 0, 5 because it's a factor x minus 5, and since the factor appears 4 times in multiplication, the multiplicity of that 0 is 4. So this way we determined the zeros of the function f of x, 3, negative 2, negative 3, and 5, and their multiplicity respectively 1, 1, 2, and 4.